can change my T0 so it agrees better? Well, my suggestion is to do things in this order and not wiggle around, but that's just a suggestion. If you want to wiggle around, you can, but I'm suggesting you go this and that order. Now, that's the best I can do with this model for that data. Are you happy about that?
Sure.
Would you like a better model? Who would like a better model? Nobody? This is a first order plus dead time model.
It's perfect.
You suppose there's a second order plus dead time model and a third order plus dead time model? This just more and more complicated?
There is a chance.
Let's stick with first order plus dead time model and do the best we can. The reason being, in a few weeks, we're going to be using those three parameters, gain, dead time, and tau, to do a design problem. We're going to design the controller using those three parameters because there's formulas in the book about that. If you have those three parameters, you just plug them into this formula and you get your controller. Is that sweet?
It's pretty sweet.
Okay, so let's not go to second order plus dead time. Unless you really want to, David, you can.
No, thank you.
We should just make the
Yes,
chart.
sir.
Yes, sir.
We should just make the chart smaller. It'll look good.
The chart's smaller and it'll look good. By the way, thanks for saying that.
No problem.
Looking good is not the objective of an engineer to his boss or to his customer. Being accurate, I shouldn't say accurate, being honest is what the job of the engineer is in talking with his or her boss or his or her customer. You want to show your defects and your weaknesses and say, this is the best we did with this model. That's all I'm asking you to do. Do the best you can with this model. All right, so any questions on that? All right. Any questions later, you can ask me. Let's go back to this other thing that we were talking about. For Excel jocks, or third person in top, that would be Ashley. Second person in red, that would be Ben. First person in yellow, that would be Caleb. Those are all three chemical engineers, right off the bat. What's that about? Third person in gold, that would be David. David, Doss, you're a chemical engineer too, right? So far, 4 out of 4 are chemicals. What's all that about? Pink number 2. You're not chemical.
Mechanical.
Mechanical, okay. Blue number 2.
I'm ME.
You're what?
I'm an ME too.
Okay, 2 MEs. So far, we got 4 chemies and 2 MEs. Green number 1. Mechanical. Fuchsia number 3. Mechanical. So far, we're tied. Okay, we're going into ivory. Mechanical. Mechanical's ahead. Orchid 1. Do you have an orchid 1 still?
Or lavender.
We're
Oh,
orchid.
where's orchid?
Right here. I'm chemical. We're orchid.
Lavender. Did you see the word lavender up there? Okay. Chemical.
Yes.
Okay. Tied. Teal. There's teal.
Mechanical.
Mechanical. Aqua.
Mechanical.
7. Tan.
Mechanical.
8. Salmon.
Mechanical.
9 to 5. I want you people to do the alternate method I sent you an email about this, but let's look at this. This is an alternate method. By the way, the graphical method that you used for finding T0 and tau so far is subject to your drawing the tangent in a certain way. That's the most inaccurate part of that process. This process has another method. It determines, it's based on determination of areas. Areas are much more accurate to calculate than our slopes. Okay, let's scroll down a bit. Here is one of your, here's a sample, an ideal response curve. Here's a little approximate. And this is not zero on your graph, it is your output baseline. And this is not zero in time, but it is where your step occurs. And this is the final steady state value, this is the initial steady state value. You draw those lines, and you calculate the area in here. How do you do that, Steve, David? This is not a mathematical function, it's data. Pardon? Trapezoidal rule. Excellent. Where'd you learn about that?
Dr. Thomas.
Who? Dr. Thomas. Good.
Next.
Well, there are other people that teach that too. Does Dr. Easton teach the trapezoidal rule?
Yes.
Yeah.
Okay, so even the non-chemicals actually will probably know the trapezoidal. So calculate that area, call it A0. Then L is what we call dead time. T is what we call time. Just different letters. Is equal to A0 divided by K. K was that height of that height of the difference here. So A0 divided by K gives you the sum of L plus, the sum of L plus T. You with me, Ashley?
Yep.
A0 has the units, A0 over K has the units of time. Finally, the area A1 is the area below the response curve up to the time of L plus T. See what that looks like. This area here. L plus T is what you've already determined. You integrate under the curve up to L plus T, trapezoidal rule again. You with me, Ben? And then, magically, you get another equation that says T, which is the time constant, is equal to the area A1 divided by K multiplied by E. Everybody knows what E is, right? 0.78. Everybody know what E is?
2.71?
Huh?
Isn't it 2.71?
2.71, I'll take that. Now, if those of you who are doing this method, because I asked you to, want to collaborate, sorry with me, somebody used the word yesterday in we have to write a macro? I don't know what a macro is. If you want to write a macro, you can. If a person writes a macro, can they share it with other people, Marion? I mean, can it be done? Huh? I'm not asking, is it possible to do that? If I write a macro, can I share it with you?
Yes.
That'd be good.
Okay, so if you write a macro to do this and you want to share it with one of these other people, or sell it, pardon?
Is it unethical to charge for it?
We don't know what a macro is.
It's not an ethics. All right, so, oh, there's another one, there's a little more there.
Each of the one.
Oh, MATLAB, if you want to do this whole thing that I just talked about, either one of them in MATLAB, I'll give you 100% bonus for the assignment. And after you've done all that modeling, load the file in File Exchange, shows these results and clearly identifies which experiments you analyzed. Week 6, Monday at noon. Week 6, Monday at noon is next week is Monday at noon. You with me, Roberto? Questions?
Ask about the times.
Oh, does anybody remember from the presentations today, was there a system that had 0 dead time?
Spring booth.
That 0 dead time
Is that
is
possible?
the best thing that you could have as a control engineer.
Is it
They
possible?
have the best system to control 0 dead time. Dead time is the worst thing that you can have. Y'all have some dead time, don't you? Y'all have some dead time, Caroline? That's terrible. So, you have an experiment that takes a long time. You get bored with it, waiting for it. And y'all too? And y'all too? So you'd like a different system?
We'd like a different system, Dr. Henry.
But what if you jump out of the frying pan into the fire and get something with dead time? Huh? That's okay. All right, I'm working on it.
Does that mean we would have to do all of
Hold
our
on a
analysis?
second. Question, comment?
What?
We need those trials.
You're willing to
We
deal
do
with
45. We do 45 because
I did 25.
I think 30.
For week 6, Monday,
Sure.
Oh, I don't do more than 3. So.
continue with the system you have. Do this modeling for the system you have. No more new experiments this week. Just apply these principles to model. All right, thank you.